Hey everyone, Mr. Mark here. Today's video, I'm going to try and explain dominance matrices the best I can. Dominance matrices are predominantly used when we are ranking teams or individuals in a round robin tournament, or ranking individuals or groups of individuals according to the influence they have over other individuals or groups. So essentially there you can see they're used for ranking. So let's go ahead and look straight at a simple example, and then we'll look at a more complex example and how we tackle that as well. So the first example I have here is we've got players A, B, C, and D that have competed in a round robin tournament. And during the tournament, A defeated D. So you can see the arc from A to D, indicating that A defeated D. B defeated A, C, and D. So here you go, you can see arcs from B to A, D, and C, indicating that B won those matches. And C defeated A and D. Again, you can see the arcs traveling from C to A and to D, indicating that C won those two matches. So everyone played 3 matches, and you can see from this network who beat who. Now what I'm going to do is I'm going to display this information on a dominance matrix, similar to the way we did a connectivity matrix. We are going to call this D, dominance. So D equals, and in row 1, we're going to be talking about the matches that player A played. Now A in row 1, column 1 can't play against themselves, so that would be a 0. In row 1, column 2, that indicates where A played B. Now A played B but lost, so we'll put a 0 there. A played C, which is in row 1, column 3, and also lost. You can see the arrows point in the other direction, so we'll put a 0 there. And A played D, which will be indicated in row 1, column 4, and A won that game. So what we're going to do is we're going to give them a 1, indicating a win. Okay, so basically 1 point for the win on this dominance matrix and 0 for a loss. Now we'll do the same for player B. Okay, B beat A. B can't play against themselves, so a 0 there. B beat C and B beat D. Player C won 2 games against A and D. So A lost to B. Can't play themselves and beat D, and player D won 0 games. They lost all 3 of their games, so we're going to put a 0 against A, B, and C, and of course in row 4, column 4, which is D versus D, which obviously they can't play. So you can see the main diagonal there is full of 0s because a player can't play themselves or a team can't play themselves. So they're indicated with the 0s. The 1s represent the wins, and the 0s represent the losses. Now, what we're going to do is use this dominance matrix to rank these individuals based on the tournament and how they went. To do that, all I'm going to do is I'm going to add up the number of wins, the number of 1s in each row. So player A, for example, had 1 win, so 1 point after the tournament. Player B had 3 wins, so 3 points. Player C had 2 wins, so 2 points. And player D had no wins, so 0 points. So this is the first example of a dominance matrix that works out really well when we've got a clear rank here. The ranking is obviously B as the first player, or the best player, the winner of the tournament, followed by C in 2nd position, A in 3rd position, and D in 4th position. There, that's, like I said, really clear. Each of those players has a different number of points at the end of the tournament, so it's pretty easy to rank those individuals. However, if we get to an example like this, where I've got a 5-player tournament and I do my dominance matrix based off of this network, which is already done for me, and I see that the row sums, some have the same value. So if I went through looking at this network, did my dominance matrix, added the rows for each player, and found that A, D, and E all finished on 2 points. That would make my ranking a little bit harder. So if I did rank here, C would be in first position, but then you'd actually find that A, D, and E are all in second position, followed by player B. Now, because A, D, and E are all in second position, makes it a little bit harder if you wanted to do a final or hand out ribbons based on positioning. So you might need to then further distinguish or separate the ranking. And to do that, what we're going to do is actually create a second order dominance matrix by squaring our original dominance matrix, okay? So what I'm going to do now is I'm just going to show you how to do that on the graphics calculator, and we're going to put that down here. So what we're going to do is we're going to find the value of this dominance matrix here, okay, squared. So D squared is equal to, on our graphics calculator, we need to head into the run function, okay, which is that one there. Now, there's a few ways of doing it, but if you're going to be reusing this matrix, which we will be a couple of times, rather than typing it in multiple times, if I click on F3 here, matrix, and create matrix A, which saves it into my graphics calculator as a 5 by 5 matrix, so 5 rows and 5 columns. So M represents the number of rows, 5, and N represents the number of columns, 5. I can then fill in this with this data here. So I'm going to put in the information. So bear with me if you want to skip through a little bit here, you can, to make it a bit quicker. So I'm up to player D now. Oops. Okay, so now I've inputted this matrix into my graphics calculator. If I press exit twice, it will take me back to the run screen here, and then I'll be able to square matrix A. So to do that, shift above the number 2, you can see MAT for matrix. So matrix, and then I'm going to put in the letter A, so alpha, and you can see above that X theta T button that I have a pink A. Okay, so matrix A squared is equal to this. So this is my dominance matrix squared. So I'm just going to write that down first. Here we go. So the first row is 0, 2, 1, 0, 1, 0, 2, 1, 0, 1. The second row is 0, 0, 0, 1, 1, 0, 0, 0, 1, 1. The third row here is 1, 1, 0, 1, 2, 1, 1, 0, 1, 2. The fourth row is 1, 1, 1, 0, 0. Oops. 0, 0. The fifth row is 2, 1, 0, 1, 0. 2, 1, 0, 1, 0. And that's it. That is my second order dominance matrix, or my dominance matrix here squared. Okay. What is it actually showing? What are the elements inside this second order dominance matrix showing? What do they represent? We know that player A in this tournament won 2 games, a game against D and a game against E. So it shows, this dominance matrix shows that player A is dominant against player D and player E. But on my dominance matrix squared, or my second order dominance matrix, it has a 2 against player A and player B. It has a 1 against player A and player C. So for example, it's actually telling me that player A in row 1, column 3, player A has some sort of dominance over player C. But when we look at this match, the results from the network here, when player A and player C played against each other, C won that match. So how can player A have dominance over player C? Well, indirectly is the answer. Indirectly, player A has some form of dominance over player C via the fact that they beat player E, as indicated on this network, and the original dominance network, a matrix, and player E actually beat player C. So indirectly, there is some dominance over player C from player A, even though when player A and C played each other, C was dominant against player A. So this shows some indirect dominance in this network. Now, obviously, there's a little bit less importance placed on this second order dominance matrix because we know that when C played against A, C won. But this one here indicates, this one inside this matrix here, the second order dominance matrix, indicates that there is still some form of dominance from player A over player C. And that is the indirect dominance that is showing up here, okay? So what we're going to do, because this is showing me that player A, D, and E are ranked evenly, I'm going to try and separate those players a little bit by creating a supremacy matrix. And to create a supremacy matrix, I can use a formula like this here. All right, so supremacy matrix is equal to the dominance matrix, this one, plus half of the dominance matrix squared. So I'm using a scalar of a half in my a scalar of a half to multiply by my second order dominance matrix, okay, which is this one over here. So I'm going to be adding this one and half of this one. Now, why only half of this one? It's because that this second order dominance matrix should be taken with a little less importance or less weight than the first dominance matrix or the first order, okay? So this half is just showing that there is more weight placed on the first order than there is on the second order dominance matrix, okay? So if I am my calculator, I'm getting it up. Remember, I've got matrix A saved in here already. Did matrix A plus matrix A, or sorry, half, I should say, plus half of matrix A squared, I would get a supremacy matrix that looks like this, okay? Now, if I add all those values up, again, with the rows, it would, and I've done that here already, so 1 plus a half, 1 plus 1.5 would give me 4. Now, and I did the same with the remaining rows there as well, so adding those all up. It would give me, I guess, a row sum that looks like this. So player A would end up on, I guess, 4 points based on the supremacy matrix, player B 2, player C 5.5, player D 3.5, player E 4. Now it has changed the ranking a little bit. So now my ranking is still player C in first position with 5.5 points. Players A and E are players, but I have separated them from player D, who's now in 4th place, and player B is still last of all with only 2 points. So this supremacy matrix has helped me separate players A, D, and E. A and E are still equal here in second position, so I can actually do this again. What I can do is I can do a third order dominance matrix. Okay, so I can cube this value. Calculator, so my graphics calculator I should get up. I would then cube my original dominance matrix. So matrix A, in this case, cubed. But again, this would have even less weight than the second order dominance matrix that we worked out previously. And you'll notice here as well that there are now some values in, row 1, column 1, row 2, column 2, row 3, column 3, etc., where A plays against themselves or B plays against itself. And we know there shouldn't be any points along there, but that comes with the cycles of adding the product of the rows and columns. So It gets a little bit messy the further we go down the second, third, and fourth order if you need to go that far. So again, you just place less weight on third order and less weight on fourth order in the case of, in particular, a ranking system based on result from a match or a tournament. Okay, so I'm going to leave it there in terms of my supremacy matrix ranking these players A, B, C, D, and E, even though A and E are still equal. If I did want to go further, I'd probably look at doing something like this. I would do another supremacy matrix based on my dominance matrix plus half of my second order dominance matrix plus maybe a quarter of my dominance matrix, my third order dominance matrix, or my dominance matrix cubed. Now these values here, the scalar in front of my first order dominance matrix is a 1. The scalar in front of my second order dominance matrix is a half. The scalar in front of my third order dominance matrix is a quarter. Those numbers are actually arbitrary in terms of they're actually kind of just made up a little bit, but you can see that they're decreasing as we move down the order. And that's all that's important. Okay, I could use a scalar of 5, 3, and 2, as long as it's decreasing as I'm moving down to show less weight on the higher order dominance matrices and more weighting on those lower ones, on the first order dominance matrix, if that makes sense, okay? Hopefully it does, because that's the purpose of these videos. I do want to touch briefly though on another example where sometimes the second order dominance matrix may actually have more influence or more weighting than the first order. And this is generally the case only when we're looking at, I guess, that second instance, if I go back to the start here, of ranking individuals or groups in terms of their influence over others, okay? Sometimes second order influence can have more weight than the direct influence, okay? So in that case, let's before I explain that a little bit more, let's look at this network. This network's showing 5 people, A, B, C, D, and E. And the arc from one node or one person to another node or another person shows either a direct influence from that person to another, or they're being directly influenced from another person. So for example, A will directly influence E, C will directly influence A and B, C is also directly influenced by D and E, etc. Okay, so the arrow is showing influence from one person to another. That is demonstrated on this dominance matrix here, with a 1 representing that, for example, in row 1, column 5, that A has influence over E, but does not have influence or direct influence over A, B, C, or D. Now, if I was to square that, I would have a second order dominance matrix that looks like this, okay? And again, although looking at this row 1, column 3, looking at this one here, although A does not directly influence C, okay, which is row 1, column 3, that's what this one's showing, there is some indirect influence via, and then I'm going to interpret this from my network, via E. So A influences E, and E actually influences C. So A can influence C via E, okay? And that's where that 1 comes from. So that 1 is actually showing that there is an indirect influence from, or A has an indirect influence on E via person, sorry, I'll say that again. A has an indirect influence over C via person E, okay? Hopefully I got it right that time. Now, let's imagine that the second order influence actually has more weight than the first order influence. Now, it might be hard to get your head around, and I might try and explain that a little bit better in a second. But basically, if it is the case, then rather than the second order having a less weight or a scalar that's smaller than the first order, like in these two black equations for a supremacy matrix, then the second order matrix will have more weight by having a larger scalar than the first order. So in the green equations, and again, like these, the scalars are arbitrary. They're kind of just made up as long as they show a decrease as you work away from the first order, or in this case, an increase as you work away from the first order dominance matrix, okay? These green ones are showing that the second order dominance matrix has more weight than the first order dominance matrix, okay? The black ones are showing the opposite, and that's what we were looking at in the first example here, when the second order had less weight than the first order. But based on this, let's say that the second order has more influence than the first order. And I've actually used that equation there. The supremacy matrix is equal to half the dominance matrix plus the dominance matrix squared to give me this supremacy matrix, which then ranks those individuals, let's say in a friendship group, and shows that this person here, which is person D, has the most influence. In fact, let's rank these. So D, who had 4 influence points, followed by C, who had 3 influence points, followed by B and E, who had 2.5 influence points, and followed by person A. Okay, so sometimes, and the main situation will be around influence, when people have influence or groups have influence. Sometimes the second order can actually be weighted heavier than the first order. Now, it is a bit hard to get your head around. I guess, a few examples where that might happen is in friendship groups where a certain person might be able to influence another person more than what that person can influence another person, right? So there might be, although these arcs are all showing the same, I guess, weight, and we're all giving them, basically a 1 point importance, that might actually be some stronger influence coming from certain individuals in that group on other individuals, which then is relayed back throughout that network. In some organizations, depending on the groups, if we look at a sporting organization, for example, it's made up of a lot of different stakeholders. There's sponsors, there's coaches, there's a committee, there's players, there's fans, and each group has some sort of influence over other groups. But then, like, for example, the committee might have a lot of influence over the coaches. The coaches have a lot of influence over the players, but then the players have influence over the fans, and ultimately the fans have a lot of influence over what happens at the level, okay? Because they're the ones that pay for the membership, where a lot of the money comes from. Now, although the coaches aren't, influencing the fans, or the fans aren't directly influencing the coaches, they indirectly are quite strongly, because the fans are impacting the committee, or influencing the committee, and the committee is then influencing the coaches quite strongly, right? So the second order dominance matrix in that case, or in some cases around influence, can be heavily weighted, or a stronger weight than the first order dominance matrix. It is a little bit hard to get your head around, but it is a little bit of fun, and obviously there's maths involved. So hopefully that explains dominance matrices a little bit better. Essentially, we use it to rank teams, individuals, using the sum of the either dominance matrix or the supremacy matrix that we come up with. Okay, so hopefully it helps. Thanks for watching.